Today we're going to use Solidworks to make a V-block assembly, including three components: this V-block, yoke, and screw. In this demo, we are going to use the three methods to put these three components together. Use a different combination of mates to make it work. And each of this group of mates will be put in the folder separately, so you can manipulate very easily. You can see there's a screw. Okay, when you turn it, and it will travel down or travel up by turning this thread. Okay, this second group, suppress. If we unsuppress this one, then it shows different combination of mates. All these three groups have the same function. Now let's get started. First, download the part, go to the course, content, week 3, lab, and you will see the base, screw, and yoke. Let's download this one. Let's create a folder. New folder. Tutorial 2. Okay. You can see we have these three parts. Now let me close everything. Start with a new part, assembly. So this one, the assembly, hit OK. So you can also use advanced to get preview if you have any part, right? So hit OK. At this moment, it asks you to choose the components you would like to select it. So I'm going to go to this document, Tutorial 2. Okay, I can select 3 of them and hit OK. Then you can see all 3 parts are displayed in this window. Open component, open document. I would like to insert the base first. You can see here. Once you put it here, it will automatically align to the this front view origin. Okay, so we add more component, insert component. So we're going to add these 2, screw and the yoke. Hit OK, and once you select all of them, then it will be able to add one by one. So you can see we have the base, we have the screw and the yoke. And if you are going to move this part, you can see the third one and the second one is movable, and this one is not movable because you already, the first component you put in the assembly will automatically set as fixed. Okay, so if you would like to make it flow, then you can do this, right click and set flow. Once you set flow, then this becomes movable, right? So we would like to make one of the part fixed. So first let's make this one visible, the plane visible. So I would like to make this plane aligned with all this plane, right? So it will be so the origin of my component and origin of my assembly frame will be in the same position. So what we can do here, we're going to mate. The first mate, standard mate, is coincident. We can make any of this, for example, front view of my assembly and the front view of my base aligned to each other. Okay, so what you can see here, a new mate is being created, and what you see here, you can see the two planes are coincident, right? So Control 7 to bring it to isometric view. I would like to move this to here, so you can see you still be able to move it. However, the two planes is always aligned to each other, and we need more constraints to make it visible, fixed. So if we look at from top view, you can see we'll not be able to move in this direction. However, we can move in this direction. If we are going to see front view, you can see we can move around on here, okay, in this direction, because this two line, okay, this two line is aligned to each other. How about in Z direction? We will be able to move in that direction. We will not be able to move in that direction, but we can move in Y direction, right? See from this view, that means we can move up and down. Okay, so that's the constraint of this constant one. Make the part front view and the assembly front view aligned to each other. Okay, let's if you select something you don't want, you can clear this selection, or you can delete this selection. Okay, so I'm going to make top and top plane aligned to each other. So top plane, coincident, and top plane. Hit OK. And then you can see I still be able to move in this direction. So I'm going to make right plane coincident with right plane. Once we're done, we will be able to see we have three mates. Once we have these three mates, then this is fixed. Okay, so Okay, I'm going to make this one in a new folder. So the base, fix the base, fix base. Okay, so if we suppress this one, okay, suppress this one, then all the items in this folder are suppressed. We can unsuppress this one. Once unsuppress the folder, all items in this folder are unsuppressed. Okay, that's if we are going to make this fixed, you can see even if we unsuppress this one, we still not be able to move it anymore, right? So, okay, let's unsuppress this first. Okay, now we're ready to move, or say we're ready to assemble the other components, the yoke and the screw. Okay, now we're ready to make the whole assembly. Because this is fixed, so we will be able to move this one and this one later. So first, I'm going to use this distance, okay, this two face, and this two face to position, and also use this face to position, and this face to position its height, and also use this face and this face for position. Okay, so let's see what we can do. Okay, delete this face. So I'm going to use, instead of alignment or distance, I know width. I know this face and this face have relationship between this face and this face, so they're centered, right? So I'm going to use this face and this two face, okay? Then use this face and this face centered. Okay, so it is centered. Okay, centered. We have other options, but for this one, centered. Okay, now once it's done, you can see from front view, I'm not be able to move in this direction because the relationship between these two faces and these two faces have been defined by this. They are centered. Alright, I'm going to do the same for this face and this face, this face and this face, then this face and this face. So by doing this, you can see there's two faces and these two faces have been centered. I'm going to hit OK. Now you can see, right? Okay, now what's next? So if this yoke and assembly and the screw and the base being assembled properly, then this face will be this two faces, actually this one face, right? So this face will attach this face to hold the load, provide the load. Okay, so what do? We're going to use standard constant, right? Constant, say this face and this face. Hit OK. Now you can see. Once I put this here, you can see 1, 2, 3. Then my yoke is being fixed, relate to the base. All right. Now let me bring it to isometric view and save my work. It asks you to rebuild, right? I would like to save all of them. Add my tutorial 2 with my initial. You would like to put your initial at the end. Now we only left the screw. How to do this? Mate. And then screw, right? What's the screw? The screw will be this out cylinder face and this cylinder face. We would like to use this too. So the two cylinder will be concentric, right? So and then once you have this, then we will be able to define the pitch. So I know 1.75 millimeter in each, and hit OK. Satisfied with all my mates. Because the other parts are in millimeter, so we should change this back to millimeter. Save it. And if you look at here, so if you turn it, then it will travel up and down. This is the assembly we created. So we're going to make this 3, 4, put this 4 in a new folder. So V block 1 assembly. Hit OK. So and rebuild and save. Again, if you suppress this one, then you will be able to move it back, right? However, this one is related to this one, right? So if we unsuppress, it goes back to here, and we need to adjust the screw to its correct position. Okay, this is the first method. We're going to suppress it. Now we're ready to make the second method. Let's bring it to here again. So we're ready to make the other one. This time we're going to use the distance between the faces to make the mates. From this side, you can see this face to this face, the distance can be calculated from 75 and 20. So if we want to make this centered, then the distance from this to this will be 75 minus 20, divided by 2. So we can make this face and this face. The distance equal to 75 minus 20 divided by 2. Okay. And we can also control the position in this x direction. Let's look at here. It says the clearance of 1 millimeter for a sliding feet is to be added to the appropriate yoke dimensions, right? So what we can do here, then the distance from here to here, or from here to here, should be 1 millimeter. So we're going to make this one and this one distance equal to 1 millimeter. Okay. Now we still be able to move up and down. So we make this face and this face. You can either use constant or you can use distance equal to 0. Either way. So we're going to use constant. Okay. Alright. If we look at in front view, oh, you can see this one is into the block, right? So that means we need to flip the direction. Okay. Then you can see front view, both sides have some clearance. Okay. Alright. Now isometric view, Control 7. This one is being fully constrained with the face. Now we are ready to create the screw. What we can do here, again, use the screw, and this time we're going to use this end again, and so distance again 1.75 for pitch. Okay. When you rotate it, you will be able to move down by rotating in clockwise, and move up by rotating counterclockwise. Control 7. Now let's save it. You can see here we put this one in a new folder. We block 2. So again, if we suppress, then we will be able to move those parts, components, I would say, freely. Okay. Control 7. Save again. Now we will be able to make the third option. Okay, now we're ready to make another mate. So this time we're going to use lines or edges to control our position. Let's put this yoke in position first. First, we know this edge must touch this face. So we are going to use this one. And this face. Hit OK. By doing this, you can see from front view, you can see whenever we move this position, rotate, right? So this edge is always aligned on this plane, right? So this will be able to rotate and move in that direction and in rotate about that direction, right? About that direction and move in that direction as well. Okay, so what we can do here, we can also make this edge coincident with this plane and hit OK. So these two mates make the part in position, so can only be moved in X, Y, X direction and be able to move in Z direction. Okay, so and this direction. So what we can do here, again, we're going to use the distance between this edge and the face. We know from previous example, we know the distance between this one and this one will be 1 millimeter, right? 1 millimeter. So let's look at front view. Okay. The direction is correct, so we accept the result. And then now this can only be rotated, right? Only be rotated about this. So what we can do here, we can make this edge coincident to distance. We can make this edge instead. This edge distance to be 1 millimeter. Okay, now front view. All right. You can see. Then with this distance, we only be able to move this yoke in this direction, right? So to limit its relationship, we can still use the edges. This edge from this face, again 25 minus 20 divided by 2. Hit OK. Now this part is the components is fully constrained. Control 7. Now we are ready to make screw. So we're going to use this surface again, similar to the previous. And then the pitch will be 1.75 meter. Okay. Control 7. And then you can see we can adjust the screw by turning the screw. Hit OK. Now we're going to put all this into one folder. So we pop insert. Now save it. Okay. If we want to suppress, then you can see we will be able to move the components freely again. I'll suppress it. Okay, so what if we unsuppress both of them? Then we will see there's conflict between those mates, right? There's some rates of conflict between each other. All right, so what we can do, unsuppress one group of this mates, then it bring to the correct assembly for us. Okay. That's the end of the tutorial.